What's up, Josh? How's it going?
Dude? I'm excited to be here. First time?
First time in Houston.
Yeah.
No,
First
I mean
time on
you
a
live here,
podcast?
right?
I
But
live
first
here.
time, first time on a podcast.
Yeah.
Yeah, that's
Yeah.
awesome.
That's cool.
This studio is sweet. We put it together on a, kind of not on a whim. I mean, we planned it, but
Yeah.
it's a pretty
Great.
pretty sweet setup.
Yeah, I love it here. It's
Um,
cool.
and
I was a little nervous driving down the south side of Houston. I live on the northwest side, so
going through traffic.
I was a little concerned that I was going to maybe miss the timeline, but man, it's great.
How long does it like during normal for people that aren't from Houston? How long? What's a normal like? Hey man, I'll meet you at 5 o'clock. How long does it take to get from point A to point B around that time?
Yeah, if you're talking about getting into Houston, you know, you can't get anywhere under 45 minutes. That's
Yeah.
just the reality is, I have friends that live out of state and they'll call and say, "Hey, look, I'm flying into Houston. Can you pick me up?" And my first question is always like, "Okay,
What time are you going to get in?
which airport actually is the
Yeah.
question?" And they're like, "Well, I'm flying into Hobby." And I'm like, "No chance. You better get an Uber because, where I'm at on the northwest side to drive down to Hobby, I mean, it's an hour and a half.
Yeah.
Easily. It's just people don't realize how large Houston is. It's just
crazy.
a massive place.
Yeah, and if you're like going to Katy, good
yeah.
luck trying to get to
Traffic's crazy.
Yeah, I mean it's 2 hours to go 16 miles or whatever.
Yeah, it's nuts. Big place. Love it. Born and raised here though. So, all my family's here and I'd love to move.
Did you go to school here?
I went to high school here. And then after high school, I actually wanted to get out of Houston, try to get away from the humidity. So I decided a good idea was to go to Columbia, South Carolina, which is kind of like the next hottest place on the planet.
It's super humid there.
So I went over to South Carolina, was there for a little bit, came back to Houston and started my career kind of.
No, that's awesome.
after
Well,
that.
so before we get too far down the road, like who are we talking to? Like
So
who are you?
I'm Josh Burcaw. I'm the executive vice president of NCFI Polyurethanes over the Geotechnical division.
Nice. And I mean, we know each other just through our manufacturer supplier relationship, and it's been really, really, really fun and cool to get to know you and learn from you and your team, and just the things that I've been in the industry a long time, and when you're in the industry a long time, you're like, oh man, I'm a big fish or whatever. And then the more you learn or the more you see like how big this industry is, you're like, dude, I'm like
not as big as I thought I was.
Or like I might be like a mid-sized fish in like this huge sea of other big fish and shark and all these other big things. But what you do is huge. And what I'd like to do is just get a little background, man. Like why? How in the world did you get into geotechnical work? Like,
it's been a wild ride. So I will say this, that I've been in this industry for so long. When I started, I was skinny, and so if that gives you any indication. A lot less gray, and I didn't have to have readers, But
I think I saw like somebody, either you showed me or Robert or somebody was like, "Hey man, this is Josh at like 20 or something like that." Or,
yeah. Oh, those were the good old days, weren't they?
Yeah, like a throwback photo,
yeah.
something like that.
So I started in 1996. Actually, is when I started in the polyurethane geotechnical.
That's awesome.
World, and so there are only a handful of us, kind of original guys, that are still in the industry, and so 1996. At the time, my dad had actually gone to work for a company called Uretech.
The guys that do like road lifting and patented the process and all that. Yeah.
So they had the patent for. The original patent was started in Finland. We can talk about that.
Yeah.
But they got the license for all of the United States and Mexico. And so through, some mutual friends and different things like that, my dad was introduced to the owner of Uretech, and they needed a vice president of operations. My dad had run large crews all over the country all over the Houston area for years in painting contracting world. and they needed somebody that could really manage crews. And so in 1996, he came over as vice president of operations, and I was just in school and looking for a job.
Were you high school then, or college?
I graduated in high school in 95, so
Okay.
it was
I was 97.
Yeah. So yeah, we're pretty close.
Same. Been in industry since when I was in it in high school, same time as you.
So I was just looking for work, and he said, "Hey, look, I'll put you on a crew." And so I came to work, and the very next day they shipped me to California, where I got to work on it was either Highway 1, the 1, or the 5. You got to say it right.
The 1.
If you don't say that right, the California folks will get irate. So
the 1.
Yeah, the 1. But everything we did out there was night work. And I had, Dad was new to his position. There was another guy that was kind of thought maybe he should have taken that role. And here's the new boss's son coming to work. So
he thought that he should have been the new boss, not the dude going to do the work on the street.
Right.
Okay.
And so they sent me, and I got put with this guy, and I think his whole goal was, I'm just going to break the boss's son. He's like, I'm going to just.
He's like taking out all his frustration on.
Yep. And so, like I said, at the time we worked nights, and he gave me a pickup truck pulling a Solaire 150 and an 80-pound jackhammer, and we did everything by hand back in the day. And so, I'm standing out there in front of the headlights of the truck on the 1, and just drilling all by myself. The crew was back with the rig, doing all the pumping, and I was out there, the solo man, drilling every single hole, and you're just talking like miles of holes. And so
back then, so is surface level not DI, or was it?
Yeah, so this just all early on.
So you're drilling like 10-inch holes.
Yeah, so it was, I think at the time we had a 18-inch bit.
Okay.
Rock bit, and so
80 pound hammer
with a 5/8 inch or 3/4 actually rock bit. So you're out there to for 8 to 10 hours a night. And so he stuck me to do all that. And so for probably about 3 weeks, this was every day. I mean, we didn't take time off. It was every night for like 3 weeks. And I think he finally realized after about 3 weeks, like, hey, this kid is not going to give up. So
you're like, break me.
Yeah. And, and I was kind of, like I said, I was, skinny and pretty good shape back in the day. And so I popped in the headphones and I just do my thing. So, so after about 3 weeks, he kind of came down there. He said, all right, hey, come here. Let me show you the ropes.
Okay. So you kind of earned like your street cred. On the
I guess. You just realize, hey, he's just not some punk that's got it because his daddy, is the boss.
Well, I mean, dude, if you're out, so you were 18 at the time.
I was,
there's not many 18-year-olds that are going to be out there grinding at night, doing night work.
No, and I've been very lucky. My dad is probably the hardest working person that I know, and was just a great example. And so, growing up, we just always worked. You're
just like gotta grind.
It's just what you do. And so, so he ended up taking me back and showing me, hey, this is how we pressure the pump up. This is how we clean the guns. This is how we drill. This is why we do it. This is, our shot count. Of how long we'd shoot. And just really took me underneath his wing. In fact, he was, to this day, he's one of probably, I can count on 2 hands the number of people that have been doing this as long as myself and him in the United States and Mexico. And he's still in the business. I count him as, a close friend.
Is he, what is he? Is he still with Eurotech? Or
No,
does he do
he's moved on, working for another company in Houston.
Okay.
And still in the polyurethane world and all that stuff. So, great friend, still talk to him all the time. But, I worked on his crew that entire summer. And so that was kind of my intro.
Okay. So,
to the world
so you did
of
that
polyurethane.
all summer.
And then.
And you were, I mean, was there any thought behind it? Like, oh, this is cool, or?
Oh yeah, I mean, I loved it. Here I am. I'm 18 years old. I'm making more money than I've ever made in my life. Because, back in the day, it was kind of one of those things that, we got per diem, so they just give you a stack of cash,
Yeah.
that we just go, and I'd eat ramen and keep all the rest of it, for months. I spent 2.5 months out there, and that summer, and so I loved it. I loved the work. Everything was always a little different. There were challenges. I loved the machinery, the mechanical part of it. To this day, it's just fascinating to watch polyurethane lift concrete.
Yeah, so let's talk about that. So you're working on, you're drilling holes. You're working on the one.
Mm-hmm.
What symptoms? What cause? Like why did Urotech become a thing? Why was there a need? What was that?
So I'll just start from like the original, if you want.
Yeah, I mean we can start there and then weave back in, and
then weave it right back in. So,
yeah, I mean it's a good place.
So the use of polyurethanes in the original Hakkinen patent was in the early '80s, and the patent was discovered and then patented by two guys in Finland. And so they were, and I forget exactly if they were
like Hakkinen, like Hawk,
the Hakkinen.
Yeah, Hakkinen.
And so that was the original lifting patent. It was a worldwide patent for lifting concrete using polyurethane foam.
Okay.
And the way they discovered it is they were either a roofing contractor spraying polyurethane or insulation, and I forget exactly.
I think they may have been like HVAC, insulation.
Yeah, they're kind of a whole bunch of different
something
things
like that.
Yeah,
maybe
but I can't remember
too.
if they were actually spraying the roof on this project. But anyways, they were working at a machine shop.
Okay.
And the guy had a big press, and they'd had a pipe that had burst and washed out a whole bunch of soils underneath the concrete. And so they'd done their work they'd been hired for, and the guy said, hey, could you take some of that stuff and just like spray it underneath the concrete? And there were two things were happening. They were getting freezing, from the ground, and so they'd ice up, and it was settled and all this stuff. And so he just, the guy just said, hey, can you just spray some of that foam up underneath there? And they're like, well, sure, I guess so. So they spray the foam up underneath there, and lo and behold, it lifts the concrete, lifts the press up. And the guy at the machine shop, he's happy, got his whole, exactly what he wanted. And these two guys went out and got a worldwide patent on the process for lifting concrete using polyurethane foam.
They're like, wow.
And then they're like, what do we do with this now? You got a worldwide patent. So they were part of an organization that met every year, a worldwide organization. And so they decided, hey, look, we're part of this organization. All these people are going to come together. How about we just license all these people across the world, with this thing? And so turns out one of the guys was a guy that from the United States. And so he licensed all of the United States and Mexico. And that's how it got to the United States in the early 80s. And it was Urotech. So the original company in Finland was called Urotech Worldwide.
Okay. And then they licensed.
And then licensed it for Urotech USA. Correct.
And then that dude went out and
licensed
all the
over
states and all these other
Australia people. And the UK and South Africa. So just kind of like all over the world.
Is Urotech Worldwide, is that still a thing, or
it's still around. It's morphed throughout the years, obviously, but no, Urotech Worldwide is still around, and Urotech USA is obviously still around as well. But yeah, so that's kind of how it all started. And then in the United States, we got it, and really what we were using it for primarily in the early days was foundation repair. The owner of Urotech USA had a foundation repair business, and so he saw the advantage of using polyurethane and just rolled it right into his piering business. And then
like lift settled slabs.
Lift and settled slabs and foundations. I mean, he was doing it in conjunction with his piering, kind of like how Groundworks is doing today. With the piering and using the polyurethane. Well, that was really the early days of using polyurethane, and then.
So that was back in the 80s, right? So that was when we still built on
late 80s,
decent
early 90s.
dirt, not as farmy land dirt that we build on now.
That's right. Yeah. And and we're in Houston. This is where it started. This is where Geotech was headquartered.
Was it Tomball?
So originally is off Hammerley in the Beltway.
Okay.
So kind of mid part on the western side of Houston, and then we moved the offices up to Tomball and built a larger office as we were growing. But so we were doing residential houses. I mean, that's what I did. I've done so many driveways and sidewalks and residential foundation repair. I've just lost count, going in and doing all that stuff.
So thinking about like the one and early on, like early skinny Josh and like skinny jeans, maybe you probably didn't drink like oat lattes back then, right?
No, not so much,
But like thinking back then, what were some early challenges that you had, like with poly itself, with the guns, with what were some early on things that kind of you had to work through that developed you and things you still remember today?
There was so many things because in the early days, again, we were doing primarily residential, and then we started this big move into the highway side of the business. And there wasn't any roadmap for any of this. I mean, we were developing and creating and figuring out all this stuff out. So when you go in and drill a hole in a house, well, how do you make that hole disappear afterward? I mean, simple things like
basic
that.
Things like you're going to drill a hole in concrete, then what?
Yeah, then what? And the one thing that really kind of took some art that you learned was, okay, I just drilled through some people's wood floor. And I can't use concrete now to cover that up. So you kind of become this woodsman, carpenter as well, because you got to use wood putty and make it disappear. And so we would carry 4 or 5 different wood putties with us and different colors. So if there was the wood grain showed differently, I mean, we'd get down there and we'd kind of mark it with darker colors to kind of make it blend in so you could just disappear. You just learn where to put holes so they didn't show up, and how do you pull carpet back, and then when you lay it back down, how do you make sure it's tight? We're kicking carpet back in, or if it's glue down carpet.
Mr. Jones, hey, will you move my furniture? And you're like,
maybe you get your son over here to move the furniture, and then we'll do the stuff. But it's crazy things that go into a commercial facility or a school or something, and all that's glued down concrete. Well, how do you cut the carpet so it doesn't
glued down carpet on concrete,
but you can cover it up, and so you got to cut perfectly so you leave these joints just right so you can glue it back in. And the equipment on the guns that we were using, GX7's been around forever. It's still the mainstay of the industry. I mean, there's some other guns out there and they have their place and they're good.
We've got time. So you want to run through it?
Yeah.
So this is what early Josh was pulling the trigger on.
This is it. The tried and true right here, the good old Graco GX7. This is a mechanical purge, meaning when you pull the trigger, there's a rod inside here that pulls back, and it allows the chemical, the A side and the B side, all of our chemicals, a 1-to-1 ratio system in the geotech space. And so that rod pulls back, and that allows the chemical to come out the tip where there's a mixing chamber inside here, and then it mixes, and then it's injected. And so, we were developing, tools like this, and the original injectors, people call them packers. I'll never call them a packer. It's an ejector, because that's what we did since day one. And
why did people them pack? Why did they say this is a packer?
In the chemical grouting world, when there are packers, mechanical packers that you'll put in the wall and use for chemical grouting and stuff, and it has a similar nature to it.
Got it.
But we were the ones that were injecting it. It's like, hey, we're injecting this chemical. We're calling it an injector. So, we designed these clamps and this injector to click onto the front of the gun, and that's
the setup.
That's the setup. Drill a hole.
You got this little vice grip.
Yep.
Well, that's welded to that, right?
Yeah. So we
we
create a plate, that welds in here, and it's perfectly set up. We're actually making some changes at NCFI to these right now. In fact, you'll notice this is a white one. This is kind of the old design. These are.
I remember you texting me about that.
Yeah.
Are those?
These are our new ones. These are the NCFI style, and so very similar. And I don't know if you can see, probably not this close, but the biggest difference is this top flange up here. Is on our blue ones is about double the thickness.
Yeah, I see it.
And the problem with the plastic injectors is when you're clamped in, and we all know that, we get a little muscly with those guns and stuff, is this top flange will snap off. And you have to be pretty gentle with it. And after you've used it once or twice, it's no good. You just can't use it anymore. So
you increase the mass of the the adapter.
Increase the mass of the top side. We use a little different material as well that's got higher tensile strength. Same setup. You don't have to alter anything, but that allows you to snap that thing in there, and you can really clamp down on it hard without snapping it off. And so you can jam it in the ground and move it and all kinds of stuff, and it keeps working really good. And so, some of that stuff. These back in the day, we called these.
So I'm just real quick. So I'm interested in like the design of this. So why vice grips instead of like making some kind of attachment where you would take like, I don't know, something that just slipped on here, had some kind of fitting, like compression fitting or whatnot. Like, who said, all right, we're going to grab some vice grips and that's just what we're going to do?
That's a great question. And I don't know, to be quite honest. I think honestly, a lot of this stuff was born out in our welding shop,
Nice.
in our office, and probably one of our guys just said, hey, look, I got a vice grip. I can just clamp something to the front of this baby. And we needed something that was quick, that was fast.
Yeah,
especially for us on the freeway, when we were trying to move down the freeway, you're doing miles at a time. You needed to be able to clamp in quick and go.
Yeah.
And this is just a really simple system to do that. And it's just kind of stuck. And that's what the injury is. So we actually have a few things going on right now. I've been working with an engineering group for some design on some new things. Kind of change that up. The front.
I mean, it's interesting. It speaks to like it's kind of like an OG.
Yeah.
Even with as complex as these systems are, and the complexity of what we do.
Oh yeah.
It's interesting. It's like, oh man, we're going to inject geotechnical polymers 40 feet in the ground. We're going to stabilize and densify some soil, and it's all held together with some vice grips
and a clamp. Yeah. And so
it's cool.
So we did. So these are some of the other things. These are our nut and ferrule. Back in the day, there was a gentleman that worked for us. His name was Bob Dandy. Fantastic gentleman. He's since passed. But he designed this, and it's called the Dandy Top. And we still use that today. But this is designed for deep injection when you are going down and you're building a lot of back pressure. We move away from the clamp and the injector setup and go to this nut and ferrule setup. And so your tubing slides up in here. We drive that into the ground, and then this clamps and creates a positive seal. So you don't have any of that back pressure kicking up to you. And then the clamp slides onto this. So the top side is the same, but you're just moving away from the plastic injectors. And so we've got those. And, something else we just started designing is in the past, the drive tips. These were
so just real quick, so that we discuss this. I don't want to overlook this for people that may not even know anything about deep injection.
And you can grab one of those tubes there as well.
So I mean, I'm a dude. I know how to lift driveways, right? And I hear people talking about deep injection. I mean, what is that?
So deep injection was actually also a patented process. That patent expired in 2017.
I think that isn't the name, isn't the phrase like deep injection still like a patented thing, or like a
no.
I thought it was. I thought it was, or like I don't know. There, being in the industry, there's like people get offended, and it's like how do I, how do I make sure that I navigate the foam world in a political way and not offend people?
We did a pretty good job trying to protect that technology early on.
Rightfully so.
And so that was one of the pieces, I mean, reality is the patent, the original lifting patent ended in 2003.
I remember when that happened.
But we still,
I don't think anybody really knew like what it was. Right.
And so we had the deep injection patent at the same time. We just kind of did a good job about making everybody believe that the deep injection covered the old patent too.
Right.
Whether right or wrong, I think anybody in our situation would try to protect something that you built as long as you could.
100%.
So the deep injection really is, the idea is when you don't have a void or a settlement that's right below the concrete, you have an issue at depth in the soil.
Right, like something deeper beneath your
4 feet, So deep injection kind of gives you this idea, it has to be like 20, 30, 40 feet. In reality, the vast majority of the deep injection work that's done is probably less than 10 feet.
Yeah, 4 to 8.
Yeah.
We worked on a facility up in Nashville where we had to work multiple depths, and we were asked to do the asphalt outside. Mm-hmm. And I remember calling you on it. I was like, hey, dude, have you ever lifted asphalt? And you're like, yeah, man, it's not a big deal. And I'm like, literally, when I called you on that, I called a bunch of other people from the industry. I got so many different people that were like, no, asphalt can't be lifted. You'll bubble it. But talking to some of the original guys like you and guys like Gibby and Andrew Jones has lifted stuff like that, and Cliff and different people. They're like, yeah, you can do it, but you just need to go
it the right way,
and you need to lift the soil so that the whole profile lifts it. Anyway, so with that, walk me through. I'm a novice. I don't know anything about deep injection.
Yes.
I'm just somebody that wants to learn what are these, right? Like how does this work?
Yeah, so
you got nut and ferrule.
Yep, you got the nut and ferrule that's going to attach to the top side of the tubing.
Okay.
And
so walk me through putting it together. I know how to put it together.
Let's go on this side just so that sticker doesn't get in your way that's on the tube. So you're going to slide the nut on first. No, not that's the ferrule. The nut on first. Yep, that one down. Other way. Flip it over.
Got it.
There you go. That slides on. Then the ferrule.
Yep.
Slides over the top, and then the nut or the dandy top goes on there. Slides on, and then you just screw it right in.
And there's no patent on this, right?
And so you just tighten that down, and it creates a compression fitting around it. You probably can't tighten it up enough by hand.
Yeah. Got it.
So as you squeeze it, it compresses the ferrule.
Yep.
And then it tightens itself around the tubing. Grips. And then you attach the vice grip right to the top of that, and you're ready to go.
And then from
the bottom side,
would
be one of these. This is your drive tips, just slides up into the bottom.
Yeah. These are the new ones that you've created that I thought was really cool, because in the field, you're having to put these tips on and tape them and do all sorts of
and so these are a polymer, and this is a sacrificial when you do this deep injection. That tip is going to get knocked off at the bottom. It's going to stay in the ground. So they used to be used. They were steel. Well, steel's just expensive.
Yeah, it's like 50 cents or
they're like $2.
Okay, $2 at the bottom. Got it. Yeah,
and so you're knocking off, and I mean it's not uncommon to have 500 injections on a big deep injection project. So you're just leaving those, and it's just all pennies and cents, and all that adds up. And so we created these since they're going to get thrown away, which are significantly cheaper, and in both sides. And so, anyways, you would take once you determine what depth is the issue, that can be either done by a geotechnical report, an engineered geotechnical report can tell you, hey, there's a weak zone of soil. Let's say
Right.
you're on a residential home, or maybe it's a big commercial facility, and they say, hey, there's a weak zone. And they usually get that through using an SPT or a DCP test.
Yeah, DCP.
Yeah,
we've talked a lot about that in the past. For that, just explore that for a minute. For those that don't know, like somebody that has no idea what a DCP test
so
is.
DCP
what does that mean?
is a dynamic cone penetrometer. And really what it is, it's a rod that has a coned tip.
It's kind of like this, right?
Similar,
it's like a rod with a cone, and then it does like,
and it
it's
just
like a hammer, kind of like.
Yep, just bangs it into the ground. It's measured in 10 centimeter sections. And as it gets hammered in, you just count the number of blows that it takes to go 10 centimeters, and that gives you your blow count. And generally, when it's something that's under double-digit numbers, we know that that's a weak zone.
Okay, so I'm just to get into the granular part for like maybe engineers that are just getting out of school and have never seen a DCP test, or contractors that are like, dude, what are these guys talking about? So just to make sure that we understand, when a hammer, how heavy is the hammer?
66 pounds.
66 pounds. Yeah. So that 66
and they're different sizes. The one we use is 66 pounds. It's a kind of a
use
small mobile.
Use the Pagani.
Yeah, the Pagani.
Okay.
Yeah, and it's a kind of a mobile unit. They have big giant truck mounted that are larger diameter, obviously, but for the one that we use, 66-pound hammer. Yeah.
So hammer comes down, and when they already lost the tip. So hammer comes down, it hits it, and that's one blow. And let's say it goes down 10 centimeters.
That we would call that weight of hammer.
Weight of hammer.
That means you've got nothing down there holding the structure.
Yep. Nasty.
Yeah.
Definitely need our services.
Lots of work.
Yeah.
Right.
All right. So go, 10 centimeters, 20 centimeters, and we're at 10. We're at 100 centimeters.
Okay.
Okay. And it takes me 10 blows on that to move that rod another 10 centimeters.
Yeah.
So that
so
would
we
mean that
we would start
my blow
saying
count
that
is 10.
Is 10.
Okay.
In that zone, and we would start saying, okay, this is getting tighter, more load bearing capacity.
Got it.
So we're getting close, and then we'd keep going and make sure that that's consistent. You might hit
so
some
like
layers.
25 would be like you're in
25.
some good,
you can put whatever you want on top of it, and it's going to hold it. So yeah. But generally, what we see is on a residence, you might see something that's 4 or 5 feet down. There's a soft zone. It could be that it's a cut and fill situation.
Yep.
If you're in a kind of a mountainous area or an area that's got hills, Texas,
I
we
thought
don't have too much cut and fill.
I thought everybody consolidates and compacts soils perfectly.
Perfectly. They're fantastic. Contractors are amazing when it gets to their compaction.
Dude, we're dialed in. We just make it
totally. Yeah.
Perfect.
I mean, you should. We really don't need to even be doing what we do because they're so good.
It's so good.
I love the fact that construction and especially concrete work and form work and dirt work keeps getting cheaper and cheaper and worse because it just means I get a lot more work to do.
It's some of that, but also arguably like when we're designing for structures or things, you can't really predict like 100-year drought. Like
no.
do you remember in Houston,
or a lot of rain,
Was it 07 or 11?
Oh,
or
which year? There were several.
there were a ton, but I remember there was one specifically. It was right before Harvey, and I want to say it was like the 2011. It was a 2011 drought that created like $1 billion worth of damage in Texas. It was like
houses were moving everywhere around here, and we were getting calls left and right. All the clay that we have through Texas, we've got a big swath of black gumbo that goes right up through the middle of Texas, up into Dallas and all that. And that stuff had shrunk up so much that everybody's houses were moving. And so we were getting calls left and right. And, we were just telling them, hey, look, we got to wait. We need to wait till rain gets reintroduced into the soil.
In the drought, dude, soils were moving like 6 to 8 inches.
Huge.
So on that, if you're a contractor, you're a builder, and you build it like, let's say your baseline level is 0, just for giggles, right? And you've benchmarked your slab, and then you go through 100-year drought, and it's dropped
There's nothing
6
you can
inches.
do about
There's
that.
nothing you can do.
You can't plan for that. You know, the best soil, you know, work that you've done, and I mean, you just can't account for that.
You can't plan for that.
No.
Because when we design in residential, we design typically for 25-year lifespan, I think.
Right.
Not a lot of people know that, but that's typical. And then in commercial, it's more like 50, hundreds.
Right. Thicker slabs and all that.
You know, and they're more thinking about, like, how long is this building going to be here? And, you know, not like a stick and brick or brick veneer house that may or may not be there.
Yeah, it might not be there
30 years from now.
Roll it over and start new.
Yeah.
So.
All right. So interesting. I want to finish with this because I want to get this out of my hand. But you know, so how are you going to get this tube in the ground when you've done your DCP testing and you've identified? You go, okay, I need to densify soils at 5 feet deep and at 10 feet deep because I've got some just wicked blow counts that don't make sense. I need to densify it. How are you going to get this rod into the ground?
So a lot of times, if it's the shallow stuff, 4 or 5 feet, you can just push it down with your hands because the soils are just that.
Yeah,
weak.
Weight a hammer is like, all right, bro.
You know where you're going. You mark the distance. You need to go in there, create the angle. You know, the old math thing, the hypotenuse of a triangle, so that you know that if it's a foundation, when you stab the tube into the ground, you're coming right up underneath the foundation wall. You can't put it out beside it, obviously. So you got to know what that intersection is. And then if it's deeper, then we generally will use like a Hilti or a Bosch hammer drill.
The Hilti's cool. It has that. I always forget the name of it, but it has that. It's the driving attachment.
Yeah, it's just got a. I mean, it's actually designed for driving grounding rods. Ground road. And so it fits perfectly over the tubing. And
so you just grab it, you put it, and then it just down jacks it into the soil.
You turn the spin part of the drill off where it's just hammering. And put it on there and it just vibrates it down into the ground to the depth. Again, same thing. You know, we always use a magnetic welding angle finder. And so it being magnetic and steel tubing, you're going to stick it right on the side. So if you know what angle you need to go down to, you know, the guy that's on the drill driving it in, he can see on that angle finder that's magnetized to the tube, he can make sure that he's driving it at the proper angle. So that, again, you intersect right up underneath the foundation wall or the footing. So
who would have thought that, you know, nuts and ferrules and dandy clamps and tubes could improve nasty soil.
But then even, you know, you talked about, you know, the polyurethane itself. I mean, it's changed significantly over the years. You know, I know when we started, we kind of had like one system, and it was, hey, you kind of got to make it work. And so whether you're trying to lift a freeway, you know, that's an 18-inch slab, and you can let it spread a long way, and that was okay. And then you had to use that same system if you were lifting a house, you know, and you're trying to lift a door frame, you know, to get it squared up, and you're trying to keep it all contained without running and moving everything else. And so you're doing these micro shots just to put so much little bit of material so it'd stay right there. And just the timing
so
it took.
Say like a micro shot, like a 1 second.
I mean, just a on off, just like a, you know, you're just spraying just a little bit of material in the ground, just because if you're on it too long, those older systems would just, I mean, they would spread 5-6 feet.
Oh, and you'd blow a slab up.
A slab up. You put so much more in there. You had no control to lift, pinpoint lifting, which is so much of what we do today, especially in the residential space or sidewalks. I mean, forget about it with a sidewalk with the old stuff, because it was just squirting out everywhere.
Or if you don't even know what you're doing and you're like, dude, I'm going to lift your sidewalk, and you're just standing there on the gun, you're replacing it.
You know, that's a great point, because, I mean, there's just this job and what we do is a craft. It really is. And the guys that are really good at it have seen lots of jobs. They've done they've
made the mistakes.
They've made the mistakes. We have a lot of people that are in the spray foam side of the business, insulation side of the business, that have similar equipment, and often they'll want to just jump into the geotech side because they think, hey, we've got that equipment. My guys know how to shoot guns and stuff like that. But it's a very different world. Very different world.
So before we go down on that, because I do want to spend a lot of time diving into what you do now, NCFI, and their role in the marketplace as probably arguably the biggest supplier of geotechnical polyurethane and in the country, at least. One of the things that, from my own experience, because I've installed piers, I've reframed pier and beams, I've gutted houses, I've injected old school
you've got
mud,
a whole wealth of knowledge, Justin. I'm impressed.
Done a little bit. I've sprayed foam on my clothes. I've done some leak sealing stuff.
I can tell you some stories. I'll tell you about a lawyer that got his entire suit sprayed. That's a good story.
That sounds like a good one. But what would you say from being in the field and being an operator, right? Somebody that operated the equipment and did what it did. How would you say that set you up to be in a position as a manufacturer? What's different? What's different between being the dude that's in the truck on the gun to being on the manufacturing side now?
Yeah. So I think it was really, there was probably 4 steps, truthfully, to get to that point. So, I worked on the crews and all that for many, many years. Got my CDL driver's license, was driving an 18-wheeler across the country, with our crew, just doing jobs all over, large scale, small stuff, and just huge projects where we were pumping millions of pounds. So, very large scale stuff, which was awesome. And then we, at one point, we decided, hey, we were doing so much road work that we had neglected the residential side of the business. And so we created a licensing division in 2000, where we licensed our patent and technology to individual people, and they started their own companies to do the residential, commercial, and work that we weren't doing because we were so focused on the road side of the business.
And that was the early on Eurotech ICR brands, right? Or Eurotech, the line.
Right. Yeah, Eurotech ICR, Industrial, Commercial, Residential is what that stood for. And so when they started that division, they asked me to come over and do all of the training, kind of set these guys up. I'd done such a variety of things at this point because there were only a handful of us that had kind of experience doing a lot of residential stuff.
Yeah.
And the roadside, because as we hired people on, they predominantly just went straight to the roadside. They didn't have this back experience of the smaller residential. So there was a handful of us that knew how to do that. But the vast majority just knew road work. And so they asked me to come over and be the operations manager. And so as they were licensing people, it was my job to go and train them, take that knowledge that I'd learned from doing it.
Yeah.
And now educating.
Passing the baton of knowledge.
And then through working with them, that really gave me insight to the business side of understanding, being profitable. How do we make this profitable? It's great we can do this, but how do we make money at it? How do we market ourselves so that more people know? Because really, Eurotech in the early days didn't market at all because we had the patent and they were, going in and doing work with the DOTs and things. So that was kind of more bid work, one-on-one relationship. There wasn't this marketing side. Well, now you've got a licensing arm that expects you, they're, paying you, they expect you to help generate business.
Yeah, generate business
leads and so I had to learn, okay, how do we do that? How do we do that?
Yeah, explain, go into a little bit of detail about the entrepreneurial portion of that, because that's something I'm super passionate about. As a young kid being in the industry, I'm literally sink or swim, eat. You got to figure out how to eat.
Yeah, it was. So, you had these guys that saw, hey, this is a cool technology, and they jump in and make the investment for the license and all that stuff. But then, you know, the expectation was, hey, you gotta teach me how to do it. And so I learned from those guys, hey, they took the risk, you know, and which was really cool. That's that entrepreneurial side, right? You know?
Yeah, they're like, all right,
something
100
new,
grand, 50,
really
whatever it is.
I don't know what this is, but it looks cool.
Looks cool. I believe in it.
We knew some people. Hey, we're starting this thing. It's brand new. You want to jump in and
help me out? I convince my wife, or vice versa. I convince my husband. Like we're gonna go.
And kudos to the first couple, which, you know, one of those was Scott Turnage, who works for you guys.
Yeah.
Which is, you know, to this day, him and his partner were our first licensee at the time. We had one in Houston, and they both came on right at the same time, which is actually your new acquisition. Now that I just remembered the leveled
guys. Yeah,
so,
they were Eurotech Gulf Coast.
Correct.
And then they did
a merge with leveled, and then y'all purchased those guys.
Groundworks acquired them. Yeah,
so it's kind of crazy. So yeah, I know all those guys down there in Houston, Molly and Joe and all them. So but Scott,
I actually spent time with them today. I'll tell you about that. It was pretty
cool.
It was pretty fun. I spent a lot of time with them earlier today.
Great people, you know, and it's been neat. Just as a side note, just the people that I've been able to interact with in this industry through years, they're just the best people.
They are.
It's a great industry.
I'd say most. I mean, there's some outliers, but for the most part, I mean, most of the people that are in this space they're
just good people. Yeah. Just wanting to provide for their families. They see an opportunity. They're hard workers, and you know, they're wearing boots just like me. So I love that. Which is a whole nother piece of how I got to NCFI, but. Yeah, so I mean, I started working with those guys, really trying to understand what it took for them to be successful, because now it's on me and the guys that were running this division to train them, teach them, and get them work, you know, so because we hadn't really done too much of that. No, there wasn't a playbook, so we're creating the playbook, me and two other guys.
So you're sitting around, and I'm really interested in that piece. So you're sitting around, you're like, dude, we got to figure out a way to market this product for these people. Mm-hmm. What were some of the things that you guys were talking about during that time period?
Yeah, so it was, you know, it was still patented at that time. And so it was kind of a tricky thing. So you're right in between this, hey, we don't want to give away the secrets and the trade secrets that we developed, the secret sauce, but we also got to tell people about this thing and help them understand of this service that's available to them. So, you know, we were putting together and probably to a large degree, we were pushing boundaries of the original owner, because, you know, he just didn't want anybody to know anything about anything.
Yeah,
you know, it was
keep it secret.
It was the old days of, you know, the GX7. If we created a brochure, you know, we had to like fuzzy out the gun so that, you know, nobody knew that it was a GX7 that they could go buy off you know, the shelf. So, you know, it was learning
like back in the days, no smartphones. Like
no smartphone. We were still rocking Nextels, you know, beep, beep, you know, the old walkie talkies and stuff. But yeah, so we were learning, you know, how to go against the peering companies, you know, without saying that we're going to replace them. But they saw that as, hey, this polyurethane, they think they can do what we can do. And that was really not the story we were trying to tell.
Right.
We were more telling a story of, hey, look, we can work together. It's a great complement of raising a foundation with piers on the perimeter, shooting polyurethane in the interior so that you don't have to destroy people's house.
Yeah, so you don't have to do like open heart surgery on the inside of the house.
And so it's just a good marriage. So learn how to market that way so that you educate the people. You don't ostracize yourself against all these peering companies that were out there. Creating brochures, you know, just trying to overcome the idea that a chemical shot into the ground is going to like create some kind of hazard.
Were you working with any marketing people back then, or was it just kind of like OG, Adobe, early Adobe Acrobat? And
the first 3 or 4 years, it was just us.
Yeah.
And one of the guys working with me was Ty Taylor, who actually happens to be my brother-in-law, and he's just a fantastic design creative. But he had worked on the roads with me from time to time. When we were younger, he had married my sister, and so he had come and worked. So he understood kind of the idea of using polyurethane and lifting and all that stuff, and had gone around and worked. And so he was able to really translate a lot of what he knew and us having done it into, graphics and to kind of tell the story graphically, as opposed to try to just verbally tell people.
Yeah.
It's just impossible to verbally tell somebody what we do with polyurethane. They're like, to this day, they're like, you're going to do what?
You're going to
with
shoot
foam?
it in the ground, and it's going to expand, and it's going to lift.
Right. And so those early days, was Ty. It was his vision of creating these pieces to tell the story, and he just did it awesome. That's just the best way I can say it, especially as Ty's a year older than I am.
So what were those brochures? What was the message?
Oh man. So a lot of it was comparing against mud jacking, using concrete slurry back in the day, because that was kind of the industry standard, as opposed to polyurethane. So if you weren't going to pier it, you're not going to pier a sidewalk. You're not going to pier a driveway.
Yeah.
Generally it was mud jacking. So a lot of those brochures were showing the similarities yet differences of polyurethane to mud jacking, with a graphic that kind of showed, how we're going to inject it with a fuzzy gun.
Were you showing, did you have a problem? Did you say
absolutely?
Sunken concrete?
We would have
a
picture of a broken concrete sidewalk, and before after kind of stuff.
You're like, hey, this is what this is the solution. This is the problem that you have.
Yeah.
This is a solution to solve your problem.
Yep.
You didn't have a brochure of a glob of foam.
No. This is, a solution to a problem. This is kind of before, after what it's going to be. We talk about, the time. Hey, instead of it taking several days to pier, we can do it in hours, cure in 30 minutes, and you can drive on it. A lot of the things that we still talk about today, we talk about and have so much more data and different things today than we did back then. But a lot of the basics, we still talk about today. It's non-intrusive. It's much cleaner. We're in and out. It's highly controllable.
Yeah.
The holes that are going to be there are going to be patched clean when we leave. You're not going to know we were there. Just all of these same things are still talked about today. But yeah, we were kind of developing all that, back in the day, creating this thing, to tell the story.
Yeah. And so this is also another topic that I really, really like, especially for those, maybe your people that are buying your product or thinking about buying a rig from NCFI, or maybe people that are like, oh man, I want to get into this industry. And I'm going to give a shout out to my buddy, Tony Sousa, who I was telling you about earlier.
Yeah.
He had this LinkedIn post earlier today that he said, he said it's super important to focus on talking about the problem that you solve and not the product that you have.
Oh, absolutely.
And I think so many people in business maybe miss that. They're like, oh man, we got this cool foam, and we got these cool piers, and this pier is better than that pier, and this has a sweet bracket or whatnot. And you can get caught up in that. But
hugely, it's a major problem in our industry. That's something we've talked about.
Yeah. If you can't deliver a clear message, then not only is it something as simple as somebody doing a hand drawing that says, hey bro,
this is what's going to look like.
That's sinking. I'm going to lift it.
Right.
Versus all this crazy, hey, this is what's going on. And
at the end of the day, I have people that, especially when they're early on, and a lot of guys just hold to this, tightly to it, is they want to talk about the foam.
Right.
And as much as I love talking foam, because that's what I'm selling, right? I love selling the juice.
Yeah,
that's all the time.
That's your job.
Yeah, but at the end of the day, that's me as a manufacturer, and that's important to you, the guy that's the installer. But you as the installer, the homeowner, you can tell them, hey, I'm shooting 4 pound, I'm shooting 3 pound. It's hydrophobic, it's hydro insensitive. It's going to have this density, that density, and it doesn't mean anything. It's amazing to me. We're about to do a training school coming up here at the end of October. We have like the geotech schools. Yeah, you've got a bunch of people
in there.
But I love to, one of the questions that I ask, because, polyurethanes are usually the differentiator is density, is kind of when you're purchasing, depending on the load that you need to carry. But I love in that class, because generally you've got about 90% in the class are people that have been in the industry for a while, and this is like extra training or freshening up and all that stuff. And I'll ask them right at the beginning, say, who can tell me what 4 pound material means? And a good 75+% of the people that have been doing it for years can't tell you what that means.
Yep.
So my next statement to them is, if you don't know what that means, why do you think a customer cares? Let's stop talking about foam.
Right.
Let's not, and then even from a pay or a billing and all that stuff, a lot of people want to charge by the pound for chemical on jobs, and that's not wrong, but that homeowner doesn't know what that means.
They don't know.
It means nothing to them.
Right. Like even just, let's unpack it. So a 4 pound foam is 4 pounds per cubic foot.
Per cubic. If you
had a free rise, if we just sprayed it right here, it rose, and I've got 1 cubic foot, it's 4 pounds.
Yeah.
And that's
the liquid chemical amount that weighs literally 4 pounds. When expanded, will fill a 1 cubic foot box.
Now, will the expanded foam still weigh 4 pounds?
It should. If it's,
I'm just saying, like,
if it's processed,
that could be like
if it's processed properly, it should still be 4
pounds at 1 cubic foot.
At 1 cubic foot, yes.
Sweet.
And so when you're testing, you can cut out samples, and so when we're QCing our material and we put it into our technical data sheets, we're actually spraying the material at normal application temperatures. This is something a lot of manufacturers don't do, which I wish they would. Is on all of our TDS, our manufacturer's recommendation is, for most of our geotech systems, is to be shot at 110. That's at 110 degrees on your A and B heater, the ISO and resin side, and your hose heat. That's our kind of the starting place. And we test all of our materials at that temperature. If you'll notice, most manufacturers, TDS, the testing that they're doing is done at 72 degrees.
I've seen
and that means that all that tells me is, if you have a manufacturer that their thing says 72 degrees, it tells me that they're not processing it through a pump. They're just doing a cup test in a lab.
Got it.
And the numbers will be very different when you actually run it through a machine at heat than what that cup test will be. Makes sense. A cup test is cooler material. It's not going to generate as much heat, which that's what the polyurethane is. It's an exothermic reaction. It creates heat, which creates bubbles, and the more heat, more bubbles, the larger the bubbles.
Yeah.
More space. So if you're doing it at 72 degrees and then you go actually shoot it and install it at 110, it's a very different product.
Totally different.
Yeah, your density changes, your compressive string changes, all that stuff. So we actually go in and spray it through the same gun, same pump and everything, cut the sample out of it, and then weigh it on an Instron, and do all of our compressive testing, tensile and shear off of sprayed material. So it's going to be very similar. Obviously, infield is always a little different, but it's going to be significantly closer in field compared to our TDS than somebody that's giving you data off 72 out of a cup test is going to be massively different. And I would caution anybody to use that data. And most people will give it to you if you ask them, but you need to ask them, hey, where's the data at 110,
at 110
or 100, or what's your recommended temperature for your system?
Right.
Ours is 110.
Because that's number one, that's its optimal temperature, and number two, that's what it's going to be in the field.
Right.
It's not going to be in a chill environment unless you're pumping in 70 or 60 degree weather. But still,
and then you're going to
it's
crank
coming
the
off
temperatures
the gun.
up. You're jacking the temperatures up to overcome that cold weather. So but yeah, I mean, so back to kind of the chemistry. We had one system, back in the day. I'm kind of taking us way back.
Yeah, no, it's totally. So,
unless you want to jump on something else.
No, this is a good place to talk about like NCFI, because you were kind of taking me through the journey of how you ended up there and all that, which is an awesome journey, and we can get back into that. But NCFI's place in the marketplace, they're huge, right?
Yes.
I mean, they're not just a little manufacturer down the street.
No, I mean, we've got large manufacturing facilities both in Mount Airy, North Carolina, and in Houston here. Our original plant was in Mount Airy, North Carolina. We built a new, just really high-tech plant here in Houston in 2001.
So what does NCFI stand for?
It's North Carolina Foam Industries is what it originally was, because it was kind of, I'll just quickly divert. So we are owned by the Barnhart Company, Barnhart Manufacturing, which is a family. It's in the fourth generation. Barnhart Manufacturing was started in 1900.
That's cool.
And they are, they manufacture purified cotton. And so think of, like Q-tips and gauze that when you go to the dentist, that's a big part of their business, is that gauze, that cotton that goes into your mouth.
It's purified.
It's got to be super purified, sterile. And so they do a ton of that. But when they were early days, in the 1900s, 1920s and all that stuff, padding was, seat cushions and padding was all textile. And so as the industry changed and polyurethane started coming onto the scene, and all that textile padding was going to polyurethane and away from, cotton and different things like that, NCFI started, or Barnhart Manufacturing started through a partnership, NCFI in 1964.
Okay.
And so that's where we got our start. And so we've been in business since 1964. Just celebrated 60 years last year for NCFI. This year, in fact, last week, Barnhart Manufacturing celebrated 125 years.
That's awesome.
Still privately owned. Like I said, fourth generation owns it. Just amazing family, amazing company to work for. When I left Eurotech after we had sold our business,
because you had an ICR part as well.
So I was in the ICR group, and then we sold that piece off, and actually we sold it back to Eurotech USA, the mother company, after patents and stuff had changed. The market had just changed.
Yeah.
It was just a good time.
It was a good time for you and your dad.
And so we sold that back, and I was just doing some consulting work after that point. And I had several of the big polyurethane companies reach out to me, trying to scout me. But I am not a suit and tie guy. And I'm a guy.
I'm not really either.
Yeah.
I can do it, but
I can
do it like once a year, or for an event or whatever, but not like I'm not rolling to the office.
No, it's just I'm not on the daily, and I'd spent really my whole career at Eurotech at that point, and so I knew that my next jump was going to have to be something where there was going to be a family atmosphere. I knew I wanted to be on the manufacturing side, was going to be something that I kind of wanted to make that change. I thought I had a lot to offer there. And so I had, some of the big boys reach out to me, but it was going to be a lot of corporate and all that stuff. And I remember I was actually at home, and I was floating in my pool one day, and Chip Holton, who's the president of NCFI, calls me and we had known each other from doing business together
throughout the years.
Yeah, and he called me and he said, "Hey, I hadn't heard from you in a while. You need anything?" At this point, I'd kind of progressed, and I was the CEO of Eurotech ICR at this point. And so at that point, I'd been dealing with most of our vendors and different things, Chip being one of them. So he calls me and he said, "I hadn't heard from you in a while. You okay? You need anything?" And I said, "Well, Chip, I don't know if you heard, but we sold the company. I'm not at Eurotech anymore.
I'm chilling in my pool right now."
And he said, "Well, what are you doing?" I said, "Well, to be really honest, Chip, I'm floating in my pool drinking a margarita right now."
That's awesome.
And he said, "Are you kidding me?" And I said, "No." And I just turned my screen time on and pointed out. He's like, awesome. "Oh my gosh." That's fun. And he said, "Well, what are you doing for work?" And I said, "Well, I just been doing some consulting stuff and not sure what the next step's going to be." And he said, "Well, hey, I'm flying in to Houston. I'll be there tomorrow." And so cool. he flew in the very next morning and said, "Hey, we've had this geotech division for a while, and we really want to grow that side of the business. And I'd like you to come on as our executive vice president and really help us take that to the next level." And NCFI is that family. Yeah. There's kind of a saying within NCFI is it's womb to tomb, just because people just work there, until you die. It's just a great place to work. Yeah. The people are awesome.
And everybody that works for you and that works for that team is super helpful.
Well,
it's like, hey, what can I?
People.
Yeah, they're just good people. Like, well, what can we do to?
I can say this without any reservation. I have the finest team of people that they are experts at their craft. They're just guys that are they want to help. They're just really good at what they do, and they love this industry. It's just a great team, and they're just the finest people. And just kind of back to Chip, I said I was really lucky to work for my dad because he's just such a phenomenal role model for me, both in business and life, and just in my own personal relationship with him is just awesome.
That's good.
But I would put secondly Chip Holton. I have been just so hugely blessed to work for him. I mean, he's such an amazing guy, just a strong leader within NCFI, but just he just kind of amazes me in a lot of areas. I mean, when we built the plant in Houston, he kind of really stuck it out there to say, "Hey, look, I have a vision of where we're going to go within NCFI."
Love that plant, by the way.
It's phenomenal.
One of the something I was going to say earlier was that one of the things that I really like is how y'all test your batches.
Oh, yeah.
So like whenever a batch is done, you do some testing on it and you log that away. That was something that was really impressive because I don't know that other people do the same thing in the manufacturing process. And they may, but
they may. I mean, most people have a QC process. And we've grown our QC process even in the time that, I've been here, which will, I guess it'll be 7 years in March. I want to finish this though, but Chip Holton.
Yeah. I didn't mean to cut you off
because this is a shout out to him because he's just amazing person that's led us well. Stuck it out there and made some big, bold moves right when I was coming on for the company, not just Geotech, but just the company as a whole that I just massively respect. And most recently, again, he's kind of pushed us out, and set some new goals of where he wants NCFI and in a couple ways, obviously revenue and growth and all that stuff. But at the same time, it's really important to him to keep make sure that we are holding on to our core value at NCFI, which is the customer is first. We're going to have that relationship with our customers. We're going to service them well, even though we're growing. We don't want our customers just become a number. So he set some lofty goals, still holding on to that tradition, that family style of doing business that I think has served NCFI so well.
Totally.
But you probably saw some, news recently. We broke ground on a new manufacturing plant in Mount Airy again.
Yeah.
And so, we had our manufacturing plant in Mount Airy. That was great, and it did awesome. We built the one in Houston. It was like 3 times as big as the one in Mount Airy. And now the one that we're building now again in Mount Airy is about 3 times the size of the one in Houston. That's awesome. And it's just going to drive us into the future. It's given us, technologically, it's going to really take us to the next level in the way we do business, our consistency of product, that QC piece that you're talking about.
Yeah.
We test every batch. I think some of the things that other guys maybe don't do that we do is we QC every single raw material as well.
Nice.
And so if we have a problem,
what are for people that don't know, what are the raw materials?
Yeah, I mean, you're talking, within a geotech system, you might have 9 different products. And so that you're talking different polyols, surfactants, blowing agent, viscosity reducers, catalyst packages, and every one of these little pieces is what gives you that end product. And it's hugely important because, you have some people that go, well, I have spray foam. Well, you can't use that in the ground.
Right.
That's a problem. I mean, there's chemicals in there that shouldn't be in the ground.
Exactly.
Like leaching and different things like
on,
that.
On what we do on the geotechnical polymer side that NCFI does, something that's really cool about geotechnical polymers and chemical grouting and the industry is that the chemical in situ in the ground is it's inert.
Right.
And people are like, really, bro? You can put all that weird stuff together and then put it in the ground and it's inert?
Yeah, I mean, if processed correctly, on a 1-to-1 ratio we train.
When processed
correctly. I mean, it's important. I mean, with anything. I mean, if you're going to go dump a barrel of A-side in the ground, that's
bad.
I mean, it's not good. You don't want to do that. I mean, luckily, it's the moisture in the ground is going to harden it up, and you dig it up and get it out of there and stuff. But the B-side is a petroleum-based product, and so when mixed correctly, it's why we harp on our training and our customers to make sure that you're on ratio. I mean, that's that. When you're looking at your dial indicators of the pressure of your A and your B side, they should be within a couple hundred PSI of each other. Yep. If they're not, you're shooting off ratio. And not only are you not creating a good end product, you're
because the product essentially is manufactured on site.
That's correct. You're manufacturing it when you make it right. We manufacture the components. You manufacture the end product when you inject it. And so it's so important that the crews are trained properly, that they know how to maintain that equipment, so that it does shoot on ratio. They need to know how to check. They need if a gauge is broken, how do you know that your material's off? I mean, well, there's really easy ways to see. If it's a yellow tint, it's got too much A in it. If it's real fluffy and white looking, it's got too much B in it. There's just all these little things, nuances that you can learn, which my team, that's what we do all day long. And it really surprises me the people that don't take advantage of that.
Yeah. Of the manufacturer support for sure. I mean, there's I've learned, there's times where I feel like I know math pretty well, and you and I have done some weird math together where you're like,
we love our weird math,
whatever. But there's times where I'm going 100 miles an hour, and I'm just like, hey, can you help me with this? Make sure my head's tracking, because I don't know if I'm I have too many things going on.
And we love it. I mean, that's what we're here for, right?
But yeah, you guys are available, and I've learned a ton through our partnership and in relationship for sure.
Yeah, it's been fun. We love it. I mean, like I said, I've done this for, it'll be 30 years this summer, and I still go out on projects.
So 26 in May. I think May of next year is going to be 30 years for me too. Yeah. Not foam, but just all the things.
Right.
All the things, foundation repair and.
Well, you're 1 year younger than me, so we basically just started off at the same time.
About the same.
Yeah. Yeah, it's still amazing. I go out on these jobs, and when you see, that concrete raise from foam, it's just magic.
That's cool.
You know, and I love it. And I love the changes that have happened.
Yeah, I was gonna talk to you about that. So the evolution of foam, right?
Yeah.
Like, so NCFI, real quick, NCFI has a geotechnical division,
Mm-hmm.
and then they have a what?
So we have 3 divisions.
Okay.
We have our geotechnical division, which I run. We have our construction division, which is, think of your spray foam insulation,
Okay.
your roof coatings,
Got
your roofing foam, you know, all of that kind of, that falls under our construction division.
Yep.
And Mitch Clifton runs that division. He's been with NCFI for 30 plus years. Just knows his stuff soup to nuts when it goes there. And then Will Jarrell runs our OEM division. And so OEM is, think of all the people that make an end product, but they need foam for the end product.
So like I'm the pillow master, or
so we used to
I've
be,
got a
if you knew Bed in a Box.
Yeah.
Okay, so Bed in a Box, that was our brand. We actually owned that business. We've recently sold that off. We don't own that business anymore.
Bed in a Box was where you like ordered
ordered online, and you cut the plastic, and it
and then it just popped out.
And then you can never put it back to try and get a warranty. It's impossible.
Never.
But no, we sold that business, and so we don't have that. But if you're a hunter and you got anything hanging on the wall, it's a very, probably a 90% chance that it's NCFI foam that mold is on. So if you got a deer mount, that's we make that. So that's OEM.
Taxidermist,
taxidermy.
There.
You know that, they put the skin over a foam mold.
Okay.
And so we are the main player in the taxidermy market, you know, creating that product. So walk-in panels, a big part of our business is metal paneling.
Okay.
And so think of like if you go into the grocery store and they've got all these coolers now, and so you've got metal, foam in between, and then metal that goes together. And so our OEM division works with those manufacturers that make those panels and designs a system that gives the correct R value, the right flow rate, so it can move through their molds and all that stuff. So we're sending the chemical to them, and they use it in their manufacturing process.
Okay.
For the end product. You know, that can sometimes cushions and things, parts, molding.
What about like snowboards, or not snowboards, but like paddle boards?
Yes. And paddleboard foam.
So my SUP probably has
who knows? It's
NCFI foam.
It's possible, And then boats, the foam that goes into boats.
Got it. Yeah.
We do a lot of that molding. Crown molding in houses. That used to be.
What about
it still
Yeti
is
cups?
Wood.
What about those insulated cups? Is that NCFI? Or is that
coolers.
Coolers.
The cups are just having airspace between them. They don't have foam in them.
I got it.
But like the coolers and things like that, we sell a lot of cooler foam. That's in our OEM side of the business. Nice. Like I was saying, crown molding is made out of polyurethane a lot these days. So
it's not old school wood anymore.
It's not. I mean, there certainly is, but a lot of it is moving to polyurethane. So we send the chemical, and each one of these systems is very unique.
Yeah.
It has to be a certain density. It has to flow rate. It has to be able to be routed, for molding and shaped, and for the rated panel.
So, I mean, how does that happen? How does a new foam, and let's
stay with the geotech side.
Yeah. And maybe something else, but like, how does you go from this industry that started like just spraying it just because somebody asked you to do it.
Right.
We had one, standard foam.
Right.
What happens, or what things happen in the field that push you to develop a new foam? Or how does that happen?
Early days, there wasn't this thing, of the term hydro-insensitive, hydrophobic. I mean, there's a difference. A lot of foams are hydrophobic by their chemical nature. But when you shoot them in water, they turn to mush, right?
Yeah.
And so one of the big turning points back in the day was we were doing a bunch of road work, obviously, and most road failure is due to water eroding, washout. Usually it's a lot of it's pumping. What's called pumping on the freeway. So the expansion joints, that caulking comes out and they don't replace them because it's not in their budget cycle or whatever. And so you got all this rainwater, and you can see how water just sheets across roads when the rain's coming down.
Yep.
And so it just runs right into those joints. That creates a soft spot. And when the cars run over it, they push that down and it just starts moving. And as it moves more and more and more, it pumps, meaning it creates a pumping action and actually squirts the water and soil up out of those expansion joints. And then it gets washed away with the rain, creating a void. And so a lot of the soil underneath roads is highly saturated. And so when we were doing work on the freeway, it became a problem when we were shooting material that would go directly into water, and it just turned into a sponge. And so one of the biggest changes early on in the foam side of the business was working with a manufacturer to create a product that could be shot directly into water and still hold the vast majority of its strength, compressive strength, and density. And that's a really challenging thing to do.
I bet,
to shoot a liquid chemical into liquid water. So we started what we just called the bucket test, which is still used today. It's public.
Yep.
In the industry.
Seen it a
lot. And the idea is you just go and we're going to hook a tube up to the gun. We're going to shoot it in straight into a 5-gallon bucket, and hopefully the material holds together.
And the 5-gallon bucket has water in it.
Has water. It's full of water. We would shoot it.
It's 5 gallons. Is it?
I forget. It's the exact. It's it's by weight. It was like 40 pounds of water or something like that, which is so everything has to be exactly. There's a DOT spec for it, but. So we would shoot it in there, and the idea is it would retain greater than 90% of its strength. In the worst case scenario, right? I mean, literally shooting free rise polyurethane foam into a bucket of water. You're pumping liquid into liquid and trying to make sure that the molecules somehow don't absorb that water and still come together and react perfectly to create a product that still has strength. That's a huge advancement, right?
And it all came from you guys showing up, having a situation where you had that challenging problem on the job.
We started.
That you had to solve.
We had some reworks.
Yeah,
that's what we went out there and did the work, and then came back and we realized, man, this is settled. And then you dig up some foam and you realize it's not great. And so
when you dug it up, it was like, this is
sponge. Just had no strength to it. It's saturated.
Yeah.
And so we had to create and work with the manufacturer to create a system. And that system was actually patented for quite a while as well back in the early days. So that we could go in and have faith that material was going to be strong.
So when you were, that was for like California probably at that time, or
actually that was for a big project that we were doing down in Orange, Texas, right on the border of Louisiana and Texas. We're Louisiana is just a swamp, and so we were working and developed that system through that time, and then through that, when the patents all went away and the industry opened up, really in 2000 and kind of 15-ish, the market was really starting to open up. People were jumping into the business and all that stuff. And you had more new, other manufacturers that were coming online, a lot more people in the business. So you're creating more buzz, you're getting more engineered projects, and obviously that forces the evolution of so many things. You have so many different systems now.
When you have that issue, testing, engineers love testing, right?
Oh yeah.
So when you have that issue, do you go back to, hey, this is why you explained what happened,
right?
Hey, this is why this happened. this is what we've developed. How do you develop, how do you communicate that to your customer, right? Because it sounds like you just took ownership of it, right?
Yeah, and I mean, and just to be completely honest, it was kind of the wild, wild west back in the day. You know, I mean, the DOTs didn't really know how to
use it.
How do you go back? I mean, most of the time, the DOTs they've checked that box. That's money spent. They get down the road, and that's the last time you talk about it, right? And, they always going back. Typically, or back then, nobody was really checking anything, but we knew there was a problem, and obviously we would stand behind any of our work and go back and do the work just as most of our contractors do. So I mean, in those circumstances when we had a settlement or a rework, we would go back and we'd inject it and get it back up. And usually once you'd shot the material, even though it wasn't hydrophobic at that time, you'd pushed the water out. So when you came back the second time, there was no more water, so you could shoot that regular material, and it was plenty strong. So it was more of an internal thing of just, we know this is a problem. We don't want to keep doing reworks. Let's develop a product that we can use in those wet environments and just be confident, because, reworks cost money. You got to remobilize, get on the freeways and all that stuff, and traffic control. That's real expensive. And so we want to mitigate those issues both for our customer and for us from a profitability standpoint. And so that was important. But, since then, there's just been so many changes, to the fast reaction foams now that we have,
that'll lift concrete
really
in 10 seconds.
Pinpoint lifting, that are, 1 second and they're kicking off, whereas the old stuff, you're talking, it's 30 seconds. So you'd be like shooting, and you had to wait to see how much it was going to lift. And you had to get really good
at waiting and
and judging and really looking around to make sure it wasn't coming up somewhere else, because it was going all over the place. And now our systems, you can pinpoint lift, with those fast materials. We have, so many materials that are hydrophobic. So if you're in wet environments of varying densities. So as the industry has evolved, you've gone from sidewalks. I mean, you could have put it into like 2 categories before. It was residential and DOT. Those were like the 2 big buckets back in the day. And then as the industry has evolved and so many more people are into it, and which is a great thing. I mean, this industry is still very much so, I would say it's in an adolescent stage now. It's not infant stage. It's more of an adolescence, because so many engineers are still learning. They're becoming more educated in the uses of polyurethanes and where they can use them, and seeing it as an alternative to old methods. But the new systems, out of doing new projects and more unique projects of, hey, we got to go seal up this dam. We got to go work at this nuclear facility. Hey, we got to go fix this runway that's 36 inches thick. That's going to take, that's got a lot more load on it. So we got to have a system that's an 8-pound density instead of a 4-pound density. We need something that's
when these new projects and the new opportunities like present themselves, how do you get together the ideas for testing?
Yeah, so we within NCFI,
or thinking about the end, thinking about, okay, there's going to be an engineer that's going to look at this. So what kind of conversations are going on internally? Like, are you collaborating with the engineers and saying, hey, how would you like to see this? Are you coming up with the testing?
Usually it's if it's something we've done, which by this point we've done so much stuff, we probably have some experience in an application that's at least similar to what's being asked of us. And so we can pull from that. If it's something just really unique, I mean, engineers typically have a set compressive strength they're shooting for. And so if we kind of know the base of what they're going for, then we'll collaborate with them and say, here's an alternative methodology, as opposed to using all these helical piers that are going to be massively disruptive, take a ton of time, very expensive. Here's polyurethane. And then we work with them to help them understand how polyurethane can be a replacement, what the design of the injection patterns would be. For instance, if we were going against a project that maybe had been originally spec'd with helicals, we'll work with them to
almost build like grout columns deep into the ground and densify that area.
Yeah. And we use a lot of case studies that we've done before, and so they're able to have that comfort level. So, I'm not the new guy, I'm not the new engineer trying to jump out on something new. So we show them a lot of, past projects that gives them the comfort level. We help walk them through the design of what we're recommending, the material specific to that project, and usually they'll see it pretty quickly and go, "Oh yeah, this makes a lot of sense." And generally, there's a reason polyurethane has been brought into it. If it's not originally spec'd, it's because there's some other challenge. It could be just if you're working in New York, it's hard to do helical piers because you just don't have any space.
Right.
Or there's a time issue. So obviously polyurethane, we can get into tight spaces. It doesn't take near as long, the impact, to the environment. We can be working in this room while they're still operating in the next room because we're not jackhammering and creating a ton of noise. So generally people are looking for an alternative to a traditional method, and it's a great opportunity for us to tell them about polyurethane and then walk them through the engineering aspects of it.
That's awesome.
And then out of that, some really unique projects, that's where we've developed a whole lot of different systems, whether that be through, density requirements. When we work for nuclear facilities, they have a whole ton of specs. So we have to have
all sorts of requirements.
High heat systems where maybe we're shooting around pipes that are, continuously 250 degrees. Well, a standard polyurethane, you can't put around that.
Yeah.
I mean, if anybody's doing that, that's a problem. So we have high heat products. We have low exotherm products, meaning, if you've got a big void, you can't just shoot regular polyurethane geotechnical foam in there because it generates too much heat. And then you can catch fire, and having a fire underneath somebody's building is not a good thing.
Yeah, or like in a tunnel.
Or in a tunnel or smoldering.
Yeah.
So we've created low exotherm systems that you can pump and pump and pump and pump, and you don't have to worry about them catching fire. So all these different things, it's because we've had a certain, need. And then within NCFI, we have a full R&D team of senior chemists for each division. So I have an entire R&D group that works with just my geotech division.
That's awesome.
OEM has a entire chemical and R&D group. Construction has the same thing. So I think that's also something that's really unique about NCFI is you don't have these chemists that are trying to do everything.
Right.
We have really specialized, and Samantha is our chemist on the geotech side, and she has a wealth of chemistry now. I mean, it's crazy, it's just like so over my head, I don't even.
Mine too.
I'm just like, Samantha, you got it. I trust you.
I'm very basic. I know if I shoot foam into the ground, it lifts X, which then lifts Y. And
so she's great, and she obviously didn't have any experience in the geotech's world. She had the chemistry side, not the real world application side, but she's just really jumped in and become really knowledgeable in the geotech space. Is part of the SPFA, the geotech division of the SPFA, and she's just been great. But then she's now helping us tweak systems and design. We're forever developing stuff, tweaking things, checking things. She's also in charge of all the QC for our products, like you had mentioned. Everything that comes out, we QC it before it ever comes out of the blend tank to make sure it is exactly what we say it is. And
so, what would you think? What do you think? And this is something I meant to ask you earlier. Is what do you think your favorite? Like, do you have a favorite project, or do you have like something or one or two or three?
Okay,
that
I have that I actually did myself, or just one in general.
A couple of them. One you did yourself, and one somebody else did. That was fun.
Yeah. So we did one project in Daytona, Florida, And this was fun for a lot of reasons. So again, I'm a college age young punk. I'm driving an 18-wheeler across the country.
Yep.
It's me and 3 other dudes. And one of them is Steve Barnes, who is one of my tech guys that works for me now.
Steve's great.
Steve's awesome. One of my greatest friends. And you want to talk about a guy that literally that guy has more deep injection experience on highly technical projects than anybody in the country. I'd put him up against anybody in the country. And that's because he was doing it while it was still patented before anybody else was. I mean, he is a huge resource for deep injection application in the field. But anyway, so we were on a project in Daytona, Florida. Steve and I, we always carried our mountain bikes in the 18-wheeler, so when we weren't working, we were mountain biking all over the place. A lot of fun stories about that. But there was a portion of a road in Florida that the story is, and I can't verify this, but there was a sinkhole originally where this road was built over it, and they threw in like 30 or 40 vehicles into this sinkhole before they then covered it with dirt.
They threw in
to fill the hole.
They just said, hey, we've got some
We needed to fill this sinkhole up with something. We've got these old vehicles, chunk them in there to fill up the space, and then they backfilled it with dirt and then put the road over it. But it was crazy when we got there because at night, you'd be driving along and you'd see the taillights of people out in front, and all of a sudden they just disappear. And then like 3 or 4 seconds would go by, and then they'd reappear. And that was the depression. So this thing was like 200, 300 feet long, 4 lanes wide, and it dropped off 18 inches in a matter of maybe like 4 or 5 feet.
Wow! And after they filled it up, and you got the cars.
Yeah, this had happened. It just sunk, and so it would drop off instantly. It was down like 18 inches for like 250 feet, and then it just pop up once you got up over the sinkhole. And so they asked us to go lift the whole thing all the way up. So we did. And that was awesome. I mean, we lifted that whole thing back up.
You guys, so that was deep injection.
Deep injection and methods. So we had to shoot down in and stabilize all the soil, and then we pushed off that to bring it up.
So you're like probably filling inside of cars and all that stuff.
Who knows?
At that point.
I mean, it was,
That's
it was a lot of material, and you're just pumping, and to see a road come up 18 inches, and you can't lift that all at one time. So we're going back and forth, just lifting it like an inch or two at a time, and all 250 feet, and then you'd come back across it, lift it, and to see that one done after it, and it was kind of a temporary fix. They were going to end up ripping the road out and redoing the whole thing at some point. But that was cool. That was pretty awesome just to see a road come up 18 inches. That was fun.
That's wild.
That was just a neat deal. We've seen so many projects, dams that were just water just gushing through them, and shooting upstream, letting the water suck the material down in there and then clog it up. I mean, you're talking a geyser coming out the other side, and you're up there shooting, and you just see it. You're shooting, and you see that just because the water's flowing through, so it just grabs your material and sucks it in there. And seeing that thing just go from a gusher and just completely stop is awesome. Big projects at hydroelectric facilities. That were really cool. I mean, a lot of just freeway. I mean, we did so many freeway things.
So the industry's evolved a ton, right? Like there's different, instead of plural component, there's single component.
Single components now,
And single components are relatively new for leak seal.
They've actually been around a long time, but
in terms of like
kind of like with polyurethanes, it's been there a long time, but they just didn't know about it. And so the industry is just educating a lot more. That was a big thing when I came to NCFI. Great company, great product. People that knew NCFI knew them as a great product and a great company. Problem is not a whole lot of people knew NCFI.
Right.
And especially in the geotech space, right? And even though we were still one of the biggest ones at that point. So, I mean, my whole thing was, hey, we're just going to start to educate the market like crazy. You know, we're going to kick on a bunch of marketing. We created our own geotechnical website and started educating the market like crazy of, hey, this is all the stuff you can do. And so it just exploded over the last 7 years. And the market has really evolved and grown, and that's been great for NCFI. It's been great for the industry. That's my whole goal, is to grow the industry, because a rising tide floats all boats, and there's a lot of business out there. There's great companies. I'm not going to dog other companies that are manufacturing polyurethane, as long as they're training well. They're
making good product,
training well. Holding a high standard of safety, so it doesn't give us a black eye in the industry, and all that. So there's some great competitors, and I'm, great. Let's go.
Yeah.
Let's grow this baby.
It levels all of us up.
That's right. Yeah.
No, it's good. And what I love that there are so many different options, from somebody that knows a lot about it. I know a lot about issues and foundation issues and structural issues, and I have a lot of different tools in the tool belt, and this one, along with all the other foams and all the other stuff that's out there, is just another one of them. But I'm constantly amazed at what you can use it for. And we could probably spend like hours talking through that. But what would you say that, as we kind of close out this conversation, what would you say to property managers, DOT people, what would you say to them to make them feel comfortable about the ground that they walk on, or what's supported on underneath? Like, their structure was built and designed for dirt, and you're putting a product in the ground that it wasn't designed for.
Yeah, so that's a great thing, because one of the biggest pushbacks that we get with engineers is they go, well, this isn't as strong as the concrete. Concrete's like 3,000 PSI, and your material's only 60, 70, 80 PSI. And I go, you're right, because we're not trying to replace the concrete. We're trying to replace the soil that was underneath the concrete. And generally, soils are compacted to 40, 50 PSI. And I said, so we're putting something. You had soil there at one point. It got eroded. It consolidated. And that's why you're calling me, is so I got to replace that soil that's no longer there. I'm not trying to change the concrete. Concrete's still strong, right? So I go in there with the polyurethane that's going to be more dense, higher compressive strength than any of the soil.
Because you're injecting it in a confined space, with load on it.
Yeah, and we always spec the material at free rise, meaning unconfined. So if an engineer specs something, we're gonna use a material that meets it, even without any confinement.
That's awesome.
So it's only going to be higher than that.
It's only going to get denser
into the ground,
with whatever loads on it, and the deeper you go.
Yeah. So making sure that engineers understand that, hey, this is not an exchange for concrete. This is an exchange for the soil that was there, and it's going to be stronger than that soil ever was when this was first built.
Yeah. And so it's about educating and making sure, and making sure people understand that it's a viable product.
Absolutely.
And it's quick, it's efficient.
It's,
way less evasive than replacement.
Right.
Way less evasive than
much more cost effective when you add in downtime. I mean, that's one of the things that we try to also educate our customers on is don't just take the cost of doing this versus this. You have to take into account what's your downtime, what if you're in a commercial facility or a manufacturing facility or a machine shop that has to be down. What's your loss of production?
Right.
What's your safety, issue? What's the liability associated with this issue? And when you take all that into account, the polyurethane becomes a very cheap option.
Yeah.
And that's what we have to sell on.
It's almost always less expensive than a replacement.
Oh, absolutely.
Especially inside of a facility or inside
absolutely.
or like if you have a culvert that's sucking fines in, like replacing culvert's crazy expensive
hugely
compared
expensive.
to sealing up.
Yeah, no comparison.
Yeah, no, it's good. So one of the things that was really interesting to me, and I'm going to get a couple points in.
Get it.
One of the things that's interesting to me, safety. Whenever you guys put your training on, you have your I forget the gentleman's name, but he talks about like how important safety is, because if you get foam inside your body, that was a joke that he had made, like, don't get foam inside your body, because if you do, like, that's a problem.
Yeah.
Because you're going to lose a finger or lose something else. But
yeah,
safety is super important.
Oh, it's huge.
I've
seen some of the worst things happen. I mean, I saw a guy using a rock hammer drill right through his foot. I mean, just literally took the rock hammer right through his foot and destroy his foot with polyurethane. I've seen so many people that aren't wearing safety glasses, and it blows out and gets in their eyes. Well, ISO in your eye turns to crystals. I mean, that's
bad.
Anybody that has worked with ISO and they go, oh man, I got crystals in my line, it keeps clogging my gun. Well, guess what? That's because you have water, and the ISO reacts with the water.
Yeah.
Well, you have that same water in your eyeball, and as soon as that ISO hits your eyeball, it
crystallizes.
It crystallizes, and it is horrible. I mean, I've had it, and I was wearing safety glasses. It came right up on the safety glass and hit me right in the eye, and it's excruciating. It's terrible for you. Making sure that you just have fans. If you're in an area like a residence stuff, just circulate fans like crazy. Even though we're injecting underneath the ground, we're not atomizing like the guys that are doing spray foam. You still just want to make sure that you're moving air, so you just don't breathe, if you're opening up drums of ISO, don't stand over it and breathe it. Just some basic common sense. Wear gloves so that you're clean. I had one guy on a project we were doing. He actually got sprayed, and while I know that a lot of guys think that face shields are stupid, and I'm one of those guys that's like, it's just cumbersome to wear on a project. I get it.
A full on face shield.
Just a full face shield, and I'm not necessarily advocating for that, but I did have a guy that shot, and it blew out, and a stream went right up into his nose. And the material went all the way up into behind his eyeball into his nasal cavity, and then expanded. And so he had to go to the emergency room, and they had to go in there and go up into his, nasal cavity, remove this foam that went up in there. And I mean, obviously the chances of that are so slim that in all 30 years, that was the only time I ever saw it. Right. But it just kind of goes back to the point that we have to be safe. We need to take precautions. Guys that are out there shooting that don't at least have safety glasses on, you're just a fool.
Yeah.
I mean, there's no way I can say it any differently. It's just
wear your PPE, wear your safety glasses.
Put some safety glasses on. Some basic things. When you're handling, one of the things we see that's become more common because more people are doing this work is people burning down their rigs.
Yeah.
And a lot of that is, I've heard, it seems to be the case is when guys take and shoot their test bags, and then they just throw those things up in the back of their rig. Well, that material in the core is still excruciating.
Being confined, and then
it generally gets to like 350 plus degrees. What happens is in a bag, it's held, and that heat is in there, and then all of a sudden, a lot of times it'll crack because of heat, and then oxygen rushes in and it catches fire, and that's why these guys have these fires. So we always recommend that if you're gonna do bag shots, just take a machete, cut the bag shot in half, and lay it out there on the side while you're doing your work, and all the heat will get out of it, and it'll be cool to the touch when you throw it in your rig, and you don't have a problem. But it's just simple things like that. Just don't throw them in the back of your rig. Don't throw them in I can't even tell you the number of dumpster fires I've seen from people throwing their test shots in dumpsters. But just some common sense stuff. If you're unsure on any of that, we are here.
Yep.
I mean, at NCFI,
you guys have provided.
We will help. You understand. Whatever needs to happen. Again, we don't want a black eye for the industry. That's just that doesn't 100%. Help anybody. And so, any of those safety questions, we're happy to address those.
I love it. So we're at the top of the hour, bottom of the new hour, whatever that is.
Goodness gracious, that
couple
blew
hours
by.
Through.
We're just chatty Cathy's, aren't we?
Pretty sweet. So one of my favorite sayings is change is inevitable, progress is optional.
Yeah.
And I think, when, especially in this industry, things change. Soil changes, people change, companies change, competitors change, people move around and change.
Sure. That's the world we live in now.
Yeah, and I talk a lot about, and I've talked to Tony about this, talked to best friends about it. We talk about it all the time, and and I'd like your take on this as we close. But something I'm passionate about when I'm training and developing, like being somebody that's been in the industry for a long time, I feel like it's our duty to train and develop people the right way, knowing that things are going to change, people are going to move, people are going to move on.
Yeah, that doesn't mean you don't train them, though.
Right. Yeah. Because the people that you train that are under your watch when they're with you, they're a reflection you're responsible, and like they're potentially a reflection of you down the road, right?
Absolutely.
They got some of their street credibility from you, and if you didn't train them right, that's going to come back.
Yeah, it's going to come
back. They're
going
to be like, oh, dude, you trained
that boomerang's coming back, baby.
No, man.
Yeah. Nah, I don't want that guy.
Yeah, that guy's not cool.
Yeah.
But no, dude. What do you think there?
Yeah, I mean, there's a couple things. If I'm talking about my employees, I mean, one, I have a massive respect for the guys that are on the job. So if I put myself contractor side, and how I like to make sure that my team is compassionate for those guys, having been on the road and been in jobs and been the guy that rolls up to a job as the operator, and the sales guy has sold something that we can't actually do, or we got to make miracles happen because of expectations weren't laid out correctly. Right. Or just the work is hard, it can be hard work. And so I have a great deal of respect for the guys that are doing it. And so I make sure that, when we're training sales guys, when we're doing sales training, stuff like that, I think it's really important for us to make sure that they understand and have compassion for the guys that are actually doing the work.
Yeah. Because
until you've done it, I recommend anybody, if you're a sales guy, if you're an owner of a business, you shouldn't hire anybody that you can't stick on the rig for a couple months as a sales guy and have them go walk in those shoes. So they know what those guys really go through. And that's kind of a sidebar, but
you're right.
Yeah. Just having, I think compassion is where I'm going, is like, all of our jobs are hard in different ways. And so having a lot of grace, for everybody when it gets tense or we get frustrated or we're irritated and all that stuff. I like to train that grace because a lot of grace has been given to me. And so I think we need to exude that same type of grace to them. But man, training well, there's so many, especially in this industry, so many intricacies. And it's why I'm so proud of our team, because they're excellent teachers. Every single guy that is on the geotech team for Eurotech or for NCFI is a guy that either was an operator,
Mm-hmm.
did it for many, many years. Well, all of them were an operator. I'll say that.
Right.
Or has been in the industry for 15 plus years. And we have over 150 years of experience,
combined experience
within our team.
Guys. Yep.
And so they're excellent teachers. And they love to train, and teach. And I think that's just what's been kind of the secret sauce for NCFI is because we take that to heart so well. But just as people in general, as leaders, I think that's kind of where you're going, just as leaders and training and developing people, probably don't do as good a job as I could. I try a lot and I care about it a lot for my team. There's always room for improvement.
Always,
right?
Man. We're all flawed and we're all human. We all make tons of mistakes. I make plenty.
But I just think, us as leaders, just being steady, I think is huge. And caring about their growth, whether they stay with NCFI their entire career or they move on. I've had a couple guys that left
and came back.
Not because they were angry or there was a bad situation. It was just they needed to be in a higher role at the time, and we just didn't have one for them. Tom Gibbs is a great example of that. When I came on, I just didn't have a role that available, and he really needed to move into a different role. He was at that place in his career. So he left, and I told him, once I get an opportunity to get you back, I'm going to bring you back. And sure enough, it was like a year and a half, 2 years later.
Yeah, that's awesome.
He came on back because then at that point I had the national sales role for him. But I think it's good to train and then also be okay if people leave.
Yeah.
It's okay. I mean,
it's totally fine.
They're doing the best for their families. As long as they leave well, and we've done a great job training them, supporting them, empowering them, paying them, all that stuff. And they've done a great job for us. It's like, hey, look, I understand if you got something
you get
that's
a better
deal,
for you, go for it.
And just know that, you can always
open.
come back.
Yeah. Man, Josh, it was awesome. I really, 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 really enjoyed it.
It's been fun.
It's been a lot of fun.
I'm gonna have to set one of these up, and then you sit in the hot seat. We'll just flip flop.
Absolutely, it'll be fun. We'll bring some peers, and what would be a fun one would be like I could bring different forms of clay, and we could set up like different clay masks and different types of chemicals that.
Yeah, we could do some foam.
Yeah,
make some foam here. Show the difference in the polyurethane. The
cooking with foam, cooking with clay.
Yeah,
that'd be money.
Well,
thanks, man. It was awesome.
Absolutely, that's awesome.